right, here's our video today, Trigonometry, Algebra 2, reference angles. We're going to talk about reference angles, and if you looked at the other videos on this topic, in Trigonometry, Algebra 2, we talked about certain reference angles already, like the 30-degree angle, the 45-degree angle, and so on. So let's get the pen going. Let's get a circle going. All right, here's our giant circle, and we'll use red. So let's just right away, let me just make the first quadrant, trying to make a straight line there. There we go. And remember, we're talking about unit circles where the radii, every radius you make is 1. Everywhere you go is 1. All right, so if I made, let's talk about the first reference angle, right? Let's say 30 degrees. That's a reference angle. And let's say over here we had 45 degrees. It's another reference angle. These are those special triangles, and let's say 60 degrees. And then we have 90 degrees. And of course, you should know them in radians, right? So 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. Those are all in radians. And 90 degrees is pi over 2. And if you don't remember how, if you look at other videos, check out the links below. But just in case, remember the formula is whatever the degree is, you times it by pi over 180. So if we take 30 degrees, times it by pi over 180, right? Remember, these can cross out. 30 goes into 180 6 times, right? So you'll be left with pi over 6. And the same goes for all the other degrees. So from the last video, we talked about how to get the coordinates of these degrees, these special angles. So let's just take the 30-degree one. So we want to find this point right here, darkening in. We already know this point, right? This point is 1, 0, because it's a unit circle. And over here, it's 0, 1. But what are the other points? So just briefly, because I went over this in the last video, if we have a line coming down here, we made a right angle, and we know it's 30 degrees. It's 30 degrees. And knowing special triangles, this is the 30, 60, 90 triangle. And when you have the 30, 60, 90, the hypotenuse will always be 2x. The angle leg A, which is opposite the 30 degrees, will always be x. And the other leg will be x square root of 3. So if we take that, if this is 1, then opposite it has to be half. And by the way, this is the 1. This is the hypotenuse, is 1. And it's 1 all the way to the edge of the circle. But from here to here, from this point in the origin to this point, it's not 1. It's not 1. It's x square root of 3. In this case, x is half. So it'll be half square root of 3, which is just square root of 3 over 2. And look at the other videos in case you don't understand that. Now look at it carefully. Let's change the colors. Use purple. So we're saying the x going this way, the x coordinate right over here, and this point is square root of 3 over 2. So if we're finding the coordinate here, let's put an arrow to tell you the coordinates. We know it's the square root of 3 over 2, because that's the x. And the y is going up and down is half. So that's the coordinate of 30 degrees. And that's a reference angle. We can use that for other angles in the video. So let's do that. Now let me clear this out. Rewind if you need to. Let's make another one using purple. Why not? Try to make a straight line. Tempting to make one. All right. So let's make that 30 degrees again. Let's say that's 30 degrees. And we'll just put a line straight down. We already know the coordinates. But it's important to know that you should know cosine equals x and sine equals y. It's important to know. And we talked about that in the last videos. Remember, sine is opposite over the hypotenuse, where cosine is adjacent over the hypotenuse. So using the 30 degrees, this will tell us, if you're looking at what's the opposite of 30 degrees, well, that would be, let's say, A. And A represents the length of y. So if we're saying opposite over the hypotenuse, which we know is 1 on a unit circle, we're saying that sine 30 degrees is going to be A over 1, or just A. Whatever, and A is the length of y. So that's why sine, I'm going to say sine theta equals y. And theta is just a Greek letter that we put in for determining whatever the degree is. Now, with cosine, it is not opposite, but it's adjacent. So whatever this length b is, and that's why it's the length of the x-axis. So that's why cosine is x and sine is y. All right, let's look at other angles. Well, let's keep that up there. Let's change to use black. Why not? Let's say I had a degree way over here. This degree over here, and let's say it's 210 degrees. So what we want to know is, what is the reference angle? First of all, let's darken that in a little better. All right. So this is 180 degrees. How far is 210 from 180? Well, the difference is 30 degrees. So we know now the angle is 30 degrees. Now keep in mind, though, each quadrant. We know that quadrant 1 is positive and positive. The x and y are positive. In quadrant 2, we know that the x is negative, but the y is positive. In quadrant 3, we know it's negative, negative for both of them. And in quadrant 4, we know the x is positive, but the y is negative. So just remember that. So whatever we're getting here, we have to consider the signs. So remember, now we know that our reference angle is 30 degrees. Because it's 180 to 210, the difference is 30 degrees. So whatever 30 degrees was, whatever we had for 30 degrees, we're going to use. So we'll make our 90-degree angle here. There's our 90-degree angle. Opposite is what? Opposite will be x, remember? And adjacent will be x square root of 3. Because remember, on a 30-degree angle, we have x, x square root of 3, and 2x. So what is, if this is 1, we know on a unit circle it's 1, the x over here would be half. But what does it represent? The half represents the length of the y. So be careful here. It's the length of the y. So we know that the y-coordinate is half, but we're looking at cosine. Let's say I said cosine 210 degrees. If I say cosine 210 degrees, all I want is the x. And the x, this is the x line. So it's going to be the square root of 3 over 2. But be careful with the sign. It's in negative. The x is negative in that quadrant. Let me do another one so you get used to this. Let's clear it out. Let's go back to red. I'll make, there we go, making our x and y graph, Cartesian grid, whatever you want to call it. So let's say, well, let's create another one. Let's say right over here, we made another one. We made 120 degrees. First of all, what's the reference angle for 120 degrees? How far away is 120 degrees from 90 degrees? Again, it's a 30-degree angle, right? See if you can find what the coordinates would be. Of course, you can't unless I tell you what we're looking for. So let's say cosine 120. So if we're looking for cosine 120, we're looking for the x. If I said sine 120, we'd be looking for the y. See what you can do with that. And by the way, just to make sure you know the terminology, vocabulary, this is the terminal side. The terminal side is here. That's the terminal side. And the terminal side is between the reference angle, what the reference angle is, and the axis. So that's the terminal side. And it's important to know that reference angles are always acute. They're always acute, right? Less than 90 degrees. So what did you get? So 30 degrees. The reference angle is 30 degrees. It's 30 degrees away. Right, let's put our little point there. So what would be the coordinates of that point? It's also, you can also say, well, it's exactly what 60 degrees would be, because that's another reference angle. So let's say we know our triangle, 30 degrees, is x, 2x, x squared root of 3. We know in the second quadrant we're going to have a negative for x, positive for y. All right, so what do we get? Be careful where you're creating your 90-degree angle. So here we are, we're creating the 90-degree angle here. There's our 90 degree. And opposite the 30 degrees is x. There's the hypotenuse we know is 1. And this would be x squared root of 3. So the y is x squared root of 3, but the x length will be half. But will it be negative or positive? So cosine 120, we're just trying to find the x, and it'll be negative half. Sine 120, we're trying to find the y, that will be positive, and that'll be square root of 3 over 2. All right, let's do one more. All right. So we have our, which one is the terminal side? What do you think the terminal side is? Get our pen going. I'll use blue. So this is the x-axis. So this is the initial side. And this is the terminal side. And we know that this is 360 degrees. Because remember, this is the line where it goes counterclockwise. So this will be 300. It's also 0 degrees, but we know we're going this way. You can see how the angle is being created here. So if this is 360, this is not quite 360. This could be 330. So it's 330 degrees. The reference angle is 30 degrees, or pi over 6. And again, remember what we did for the reference angle. Get in there, we have 30 degrees, we have the x, 2x, and x squared root of 3. So here, if we make our 90-degree angle, there's our 90-degree angle. Opposite will be x. So the x this time is represented by how long the y is. And this would be x squared root of 3, the initial side over here. So, of course, you can't answer this until I tell you, well, are we looking for cosine 330 degrees? Well, let's do it. Cosine 330 degrees. Looks like an 8. Let's do it again. Cosine 330 degrees. So what is the coordinate? What is the x? Now, don't get confused with this x. That's just showing you how the ratio for the 30, 60, 90 triangle. So in this case, this is the y length. We're looking for this length. We know that cosine, the x, would be square root of 3 over 2. And it's positive because x is positive in this quadrant. Now sine 330 degrees would be negative because it's negative in that quadrant, and it'll be negative half. All right, so that's reference angles. So it's just really important just to remember what sign you're doing. Like again with the 120, I want to make sure we understood the 120. When we did the 120, this was 120 degrees, and we made our reference here. This is the 30 degrees over here, and that would be x. Remember, if we're looking for cosine 120, the x would be half, and it would be negative half. And why is it negative half? Because x is in the negative zone on quadrant 2. It's negative positive. All right.